G'day champions. You've probably seen a million videos about this amp by now, but have you seen one with an Australian accent? I don't know. So you're probably here because you've got a problem with your amp, and it's one of the Blues series, Blues Junior being one of the most common. It's a nice compact little amp, just the right power level. Doesn't sound great, but it sounds passable. Its cleans are okay. Sounds a bit boxy and woofy. The overdrive's pretty terrible. Cook's output valves. Has a few other little issues. So let's have a look at it. We'll have a look at the common problems, the common fixes. This particular one doesn't really have any major problems, but it will. So we have been tasked with basically road hardening it a bit, future proofing it a bit, toning down the bias so it doesn't eat through valves so quickly in the future, and just making it a reliable, decent sounding amp. We're going to tighten up the bottom end a little bit. The valves are okay. It looks like someone's replaced the speaker in the past. It's got a Patriot Cannabis Rex in there by Eminence, so that's an improvement. I personally wouldn't have chosen that one, but it's a taste thing. I really like the ET65 in this amp. It really rounds it off. It's nice. So let's have a look. We'll open it up carefully. I'll show you how to do that in one moment, and we'll go from there. So the first thing that happens with the Blues series is people undo these screws, can't pull the back cover off. You may have seen on other channels, or Lyle's channel, where he bemoans that. The reason is there's screws into the chassis on either side. You want to back them off so they're about, I don't know, a millimetre or so above the Tolex, just so there's a bit of play, and these sides will open out a bit then. And then we can remove the back panel without breaking it at this thin point here, which is very common. So I try to use a screwdriver where I can, just to limit any chance that the drill's going to go and ream the screw head out, because it happens quicker than you can react if you're using a industrial type of impact driver or something. So we'll just go over a few of the weaknesses inherent to this amp. The speaker cable likes to break in this little bit here. You can see it's got a bit of a kink to it already. So I suggest replacing that end with well, just replacing the cable straight up. But if you wanted to reuse that, you could just use a proper switchcraft or a Amphenol right angle jack. That's a lot better. The spade connectors I'm not a big fan of, especially when you can undo it from this side. There's no real need to have spade connectors, so just snip them off, strip a bit of wire, and actually solder them to the speaker tags. You can see down inside there. Just remove any source of intermittency, because these things like to cook their valve boards if there's a flyback event. They do have flyback diodes, but they don't seem to work in this model, and you get arc damage to the circuit board, which is quite common. So common, in fact, that I made a replacement, Brad's Guitar Garage replacement, with a few of the weaknesses in that board removed. But we'll go over that in a minute. So one thing a lot of techs bitch about is this valve retainer, you know, U-section thing. It's never really bothered me. It's a bit annoying because the springs go flying when there's no tension on them, and they're a little bit of a pain to reconnect, but I've never really had any fail on me or do anything to the valves. It's got little rubber grommets in there, so they sort of have a cushiony surface to the valve. You know, wire retainers would have been fine, but whatever. If they want to spend their money bending up a custom piece of metal and drilling it, then good for them. So we'll just have a look at the valves. These look to be the original GTs, yeah, from Fender. Just have a look at the sockets, see that there's no schmoo in there, or some idiot techs smear grease in there for some stupid reason. So always check that, because dielectric grease in a contact, anyway. But yeah, they all look good. As part of a service, I'll just give them a clean as well, the sockets, but they're all looking okay, and they're very tight. So moving on. So of course I'll test these caps for any residual voltage on them before sticking our hands in there. 0.2 volts. It's good to check right on the capacitor if you can access the leads. It's a bit difficult if it's a radial. 0.2 volts. Wouldn't even feel that if you licked it. So it might be a little bit hard to make out, but you can see these are nice and clean at where the lead exits, and this one's got a bit of crustiness to it. Excuse me. Heater leads coming from the other side, just down there where the lead exits. There's a bit of crustiness. Now that's the electrolyte starting to leak, and it happens to all these ICs. This is a Fender Blues Junior 3. So when the 3 came out, there was reports, oh, all the IC caps are good now, it was just a bad batch, everything's good, the bias is fixed. No, it's not. It's the same as the previous one. Then when 4 came out, oh, the IC caps are good now, oh no, they're sweet, they solved all the problems, and they fixed the bias. No, they didn't. They haven't fixed it on any of them. So just don't believe what you hear on the forums. It's probably Fender paid trolls. Who knows? I've even heard that the latest one is cathode bias, but I'm yet to see it. Well, I'll believe that when I see it. There might be some info out there I should update myself. But so far, every one of them's had the inherently same problems every generation, and basically nothing's changed except the cosmetics and the badge on the back that says 2, 3, 4. Go marketing department. So there's something about amp manufacturers, they seem to hate EL84s because they flog them like rented mules. They give them about 100 more volts than they're rated for on the plates, and they run them at 100, 150 times the maximum dissipation rating. If it's 100% on a cathode bias amp, even that's a little bit warm. You want a bit of a margin for mains fluctuation. But having a fixed bias amp run at over 100% is just inexcusable. They should be max 70, more likely 60, more comfortably 50 if you want long life out of your valves. But every one of them just runs them way over spec. Now, if you only had to change your valves every year or so, then if you like the sound of the amp, so be it. Make that sacrifice. But what happens when a valve fails is a little bit, all bets are off. So the valves overheat. This board down here runs hotter than it should. It melts its own solder connections and burns the pads. So that copper foil on the PCB there's no magic there. It's just copper glued to fiberglass. That glue has a certain point at which it degrades and stops being glue, basically. And the copper traces let go of the circuit board. And then your circuit board's rooted. That's the Australian term right there. Look it up, Urban Dictionary. So then your board is buggered. You get cracked solder joints first. Chances are the actual solder pads don't crack initially unless it goes bad real quickly. That's your first sign of trouble. When you start getting crackling and stuff, you take it to a tech. They have a look. If they can save it in time and pull that bias back, so be it. You can keep the board, and about 50% of them, or probably 75% of them, you can save that board. But when you can't, either your tech is honest with you and gets the proper parts, either from me or from other manufacturers or other small-time manufacturers who manufacture replacement boards, or they hack it together and cut bits out and glue things and fill things with epoxy and just, I'll show you. Hang tight. So here's your typical local amp guru, self-professed, and what they do to your Blues Junior when something goes wrong. So let's try and unfold the logic here. So they had a burn section here, so they just dug it out and they cut this here and they ran wires. That likely was more reliable, although ugly as hell. But what happens, more reliable in this method anyway, we'll get to that in a moment. But what happens is the pads start letting go and you lose all mechanical structural support for the valve socket, because it's only relying on these pissy little pads just glued to that surface for all its mechanical strength. And now you've lost 1, 2, 3, probably going to lose that one, 4, 5 out of 9. Yeah, you're just going to start losing more and more because there's more and more movement. The remaining ones are going to start failing as well because none of these pads want movement. Now you'll notice these are the two EL84 sockets. Preamp ones don't go so bad. The main reason for casualties there is because tech has a shitty soldering iron, or the wrong temperature, or the wrong solder, or is just heavy-handed or impatient to wait for the solder to reflow, or uses the wrong solder, or just basically has no idea what they're doing. Using a Bunnings soldering iron, if you see a Bunnings branded soldering iron, or whatever their generic brand is, Benzomatic or whatever, in your tech's workshop on his main electronics bench, take your amp and leave. It's as simple as that. So here's one that looks better but isn't. So you can see it's lost the same pads. This pad here is, they've just gobbed on more solder. What happens when you do that? The glue has already made the foil let go. So globbing solder on there just makes, instead of the crack being here, now the crack will just occur here. Same with the pads. The ones that are less bad, the round pads, they've just got more solder on here in hope that, I don't know, it's magically going to stop moving, and then you'll just develop a crack here. So it really does nothing. It works enough for them to collect their bill, and it might even last the whatever tail light warranty they have, and then you'll come back and they'll go, sorry. So this kind of saving money is not saving anyone money. When they say, oh, you don't need to replace the board, you could just repair it. Well, yeah, that suits them because they get their quick little pump of cash and you get pumped. So the better way to do it is, I know this is a bit extreme, but I designed my own circuit board. So this has a few other features. So you've got some bias opportunity to add some cathode resistors there for safely checking bias. You don't have to deal with the plate voltages. But the main improvement is it's thicker fiberglass. That's 2mm instead of 1.6. The copper plating is 2 ounce per square meter, whereas the normal stuff is 1. So you've got extra structural stability in the actual foil itself, less likely to crack. This is a higher temperature rated FR4, and all the holes are through hole plated. So you can see down in there, the holes are shiny within the hole. And then on the other side is another pad. Now that's like a little tube of copper in there as well. So each pad is like a little rivet. Same for the screw holes, just by coincidence, because that's the easiest way to design them on the software. You can leave just a hole with no pad if you want, but I think it looks nicer, and it doesn't munch up the lock washers don't munch up the fiberglass when you do it up. It looks a bit crappy after a while if you undo it a few times. We've got isolation slots between the high and low voltage pins where required. Where they're not required, I left them off because it's an extra route. You've got heater traces that are in exactly the same position as closely as they can be, top and bottom, for either side of the board. So I've kept them as far away from all the signal pin, all the grids and anodes as I could, and had them directly on top of each other so we had the best chance of them cancelling out. So that should give less hum. And we've got a little position here for your bias test point, so you don't have to go probing right into the valve socket area. You got one there, and they work in conjunction with, if you put 1 ohm resistors here and here, then you can directly measure the amount of milliamps that that valve is conducting through the cathode to ground. So you can use that to calculate approximate bias, including screen grid current, but if anything it puts you on the safe side of the dissipation. And of course we've got a wanky logo. So I sell these to other techs, I don't sell them to just general users, because I want someone who knows what they're doing to install them. You can reuse the existing cables. I've set them at the same width. If they're too munted, I've got some replacement cable of that type which can be used. You can use individual wires, but it ends up a little bit messy. I've seen a lot of other techs do that well, and I've seen a lot of other techs do that very poorly. So that is worst case scenario. we don't need it in this case because this one's in good condition. So on we go. Now this amp looks legit from the outside, but when you look at the inside, the dirty truth is revealed. She's not your average Fender, right? So it's got an LED for the lamp there, not your average big chunky incandescent light like you used to see in the vintage Fenders. So it's works, whatever, but it's a little bit fakey. But you know, if it does the job, it does the job. These pots, they're circuit board mounted, so they've got no structural fixing to the actual chassis. They've got a little bushing in there which stops the shaft from wiggling around and limits the movement a bit, which is good. But what often happens is people lose them, and techs lose them. I've had amps come to me where other techs haven't put them back on after they've serviced stuff, so that's not great. If you use them, it's fine, but there is always inherent end play there. So if you push on the knob, that pot tries to tilt backwards, and the only thing stopping it from going backwards is the solder joints. And what happens to solder joints when you push them back and forth? They crack. So that's a weak point. The other thing is this jack. Circuit board mounted, they almost always crack their solder joints after a couple of years, and the thread is very short, barely holding onto the nut, and the thread is very fine and easy to cross thread. So you often, again, if owners have tried to have a go at it themselves, or techs that are a little bit less savvy try to do it, they cross thread them and they strip that thread off. So that's not great either. You can replace them with just a switchcraft and just hardwire it, which is cool. So you may have noticed here I clipped C1. Now that's the bypass cap for the first stage, which is 47 microfarad. That's a lot of gain and a lot of bottom end to pump into this small cabinet. The biggest issue with this amp, in my opinion, is the tone. Now the distortion's pretty flubby. It's got a nice clean tone, but when it starts overdriving, it doesn't happen smoothly. It happens sort of abruptly and not very gracefully. It doesn't have a nice smooth transition into overdrive. So for the customer, just to demonstrate extreme demonstration, I just snipped that cap out to show them what it would be, how different it can be, just with a different value there. I tend to land, depending on the tastes and the guitar that they're using and the styles they play, I land somewhere between 1 microfarad to 4.7, and yeah, that's the order of magnitude smaller. Gives less gain, but it also drops the bottom end, tightens the bottom end up a little bit, so it makes it a much more usable amp. And I have not had one customer that's complained about that. They've all been over the moon once they've heard it afterwards. So onto the bias supply. That's these two resistors here. They form a resistive divider from the bias supply to ground, and then from the center point where they meet, you get the bias feed to the output valves. So that, as it becomes more negative voltage, pulls the valves back and they conduct less, so they dissipate less power. As it approaches 0 volts, so goes up in voltage relatively, the valves start conducting more. So the voltage that it comes from the factory with needs to be reduced, so made more negative, in order to pull the valves back from the brink of suicide. So you can do that with a simple resistor change. It's fixed bias, but it's unadjustable fixed bias. It's a bit of a misnomer. People get confused. Fixed bias doesn't mean that the bias voltage and the bias point's not adjustable. It just means it's not cathode biased. It's got a negative supply going to the grids. So what we can do is just change those two resistors, or we can use what my friend from Keld Amp Works in the UK, thank you Rowan, he makes these little boards, and they are the same footprints as the resistor, the two resistors there. So they mimic those two resistors, but you can use your own values. Surface mount too, I might add. You can use surface mount resistors. He's got the pads there in the middle. Looks like 0603. Or you can use through hole standard quarter watt resistors there, and you can put a trim pot there and make the bias on these things adjustable. There's a nice little landing there, which I suspect he saw that and ooh, what can we do with that? So that board sits nicely on there. You just link a wire through, and you can put maybe a dab of silicone under it just to lock it in place, and you've got adjustable bias in your Blues Junior. So that's pretty cool. I'd hit up Rowan if you want to get one of them, or get one to your tech. There are guys that just sort of coat hanger one off the holes, but this is circuit boards are so cheap these days. If you know how to make them, it's a really more reliable, more professional looking and longer term solution, less prone to damage or degradation. So while we're talking about little gadgets, Rowan also makes these things. Axial and radial caps are two different styles of capacitor. So axial, as the name suggests, means that the leads come out either end, plus and minus, positive, negative, and radial means that they both come out of one end, and your negative's marked on one side with the wrap there, and your positive's not marked at all. So axials used to be sort of state of the art because a lot of things like radios, consumer stuff was built point to point, and it made sense because you're going from one place to another. If you've got nice long leads, your options are wider for where you can connect that capacitor from and to. Whereas these days, radials are designed because everything, radials are used for PCB designs because everything's on a PCB these days, and they want to stand up, they want to be as small footprint as possible, and the leads both get connected to the bottom of the circuit board. So these are designed so you can use radials in place of axials. So you go through the leads there, you lean that thing over and silicon it to it, and then you just put little link wires through to where you're going on the board, and it's the same width. So it's a little adapter without having to do any weird bastardry with you know, heat shrink going over the top, and you know, it just looks more professional. And eventually you're not going to be able to get axials, basically. That's the state of the art. So one day it's going to be either very specialized, very expensive, and of course when someone has a monopoly like that, they don't tend to regulate their quality that well, so the quality will end up hit and miss, just like we're seeing in the valve world now. Whereas the radials are much cheaper, much more efficient, much higher spec, and readily available is the most important part. So these allow you to use the radials instead of the axials. In this case, I've got enough axials to go on with, so we'll do that. And if we ever end up in a pinch, well, you know, you can get some of these off Rowan, or you know, of course you could just wrap the lead over the top, but yeah, I don't like the look of that. So let's get to work on this thing. I like removing all the valves just to eliminate any risk of damaging them while we're moving around, or they just get caught on the multimeter leads and stuff. Just another layer of safety, mate. So I'll snip out those caps because we're changing them. Best way to do them is I snip them as close as I can to the board surface. And then I grab a set of pliers, just lift them up by one end. They tend to pop off like that. That one is gives us a little bit of a leverage point now. You can roll them off like that as well. That tends to be a bit more gentle. There's silicon to the board. Just be careful not to damage any surrounding components. Put them aside. Now we've got little globs of silicon there that we want to remove. We want to put fresh silicon there on a flat surface. Silicon would probably stick to other silicon, but I don't know what formulation they use, blah blah blah. So I've got a little rounded chisel here. It's like a luthier's chisel. Generally a joiner or a cabinet maker or a carpenter's chisel is hollow ground, goes that way. Luthiers have to use their chisels as little planers, and by having that curve on there, changing the angle of your hand, the angle of the approach determines how much material you're removing. So you can go from removing almost none to digging right in, and polishing the underside is just just to get it sharper. I've got a buffing wheel on my grinder at home where I sharpen them all, and that takes the burr off, because these things, when I finish sharpening them, they're shaving sharp. They'll easily shave a strip up your arm. But they tend to get a little bit abused down here, whereas at home my chisels are pristine because that's where the woodworking happens. So I just come in at a angle where it's just starting to bite in, and I just sort of shear it off like that. You can see there's still a bit left because I was pretty gentle with my angle. You can go a steeper and take the last bit off. I don't want to take the writing off the board, the silk screen, if I can help it. It's just easier to do all this stuff while the board's still attached, instead of flopping around unfixed from the chassis. Alright, then move on to the bigger cap, 47 oof. Sweet as. We've got silicon crap everywhere, I'll just vacuum that up. Now in order to swing this circuit board out, we'll have to get a bit more leeway from the leads, so we need to remove these mental blank. What do you guys call them? Zip ties? We call them cable ties. Crazy differences in our languages. So now we'll have enough movement in the wires to swing that board out and work on the solder side without having to fully disconnect everything. I pull the LED out as well, just so we've got one less thing trying to hang on. So we're just onto the top panel now. We're going to remove the knobs. This is the version with the black control panel, white writing. Previous ones had a chrome plating on the top panel there, and it would rust through and you lose all your lettering. It looks pretty terrible after a few years, unless you've absolutely babied it. There are third-party makers on eBay of vinyl overlays that you can stick to the chrome ones once they're fully routed. And I think you can get them available with the writing pointing towards the front or towards the back. Traditionally the Fender amps had the writing towards the back because the guitarist would sit behind the amp, and the amp was the PA, and the guitarist was supposed to sit behind it. These days you've got it as a back line, you've got it towards the back of the stage, you walk towards the front of it to adjust it, so it makes sense to have the writing pointing this way. These are the little bushings that they put in over the pot shaft. So they've got a shoulder to them. That shoulder sits in the metal hole, and then this is like a spacer for the knob. So they all sit at consistent heights, and limited wiggle is available. They still do have a bit of movement. You just can't beat bolting a aluminium or metal shafted pot to a chassis. I'm going to get rid of them and don't lose them. Onto our jack, and again they've got really thin coating, like the nickel just wears through by looking at it. So I have a set of these for tightening and loosening pot jacks, switches, you name it. They've got a little grip on the side there, which for plastic bushing jacks and stuff is generally enough torque to undo them without damaging them. If it's a metal one, you just go into the 1/4" square drive on the back. We'll just undo the circuit board screws. These are actually really loose. Barely holding on. Check the fuse ratings, they're correct. Always do that. Don't ever trust the previous person to put the correct fuse in it if anything happened. People will say, oh, I just put a temporary fuse in there until I could get the other one just to get through the gig, but guess what? There is no more permanent solution than a temporary fix. We all know it's true. Now to get the board out, we've got to disconnect the primary connections on the output transformer so they can pass over that little gland down there, and to get enough clearance for the board to move and the pot shafts to come out and clear that lip, we need to remove the foot switch and speaker jack board, and we should be able to carefully get it out. These ribbon cables do offer quite a bit of resistance. And there we have it. Now while this board is a pretty nice specimen, pretty unscabby, you can see someone's gone in and touched up some solder joints before. They've got flux on them, and the rest of them don't because they were washed at the factory after the wave soldering took place. There's been some spade connectors that have been reflowed there, and we're starting to see some minor rings around the pins on the pots, which is indicating that cracks are starting to happen, so we'll reflow them as well. And someone has reflowed the jack, so I think we might replace this jack because it's a bit wobbly, and the plastic casings seem to come apart on these, because although they do their best to align the holes on the circuit board with the holes in the chassis, if they're a little bit out, it puts a lot of angle sort of load on that little plastic box, and the little clips that hold it together come undone. You often see the arse is coming out of them. So we'll replace that with a switch craft.